All right, in this lesson, we're looking at blood components. Now, this is a slideshow, so just so you know, it's quite wordy. So if you'd like to write some stuff down, then pause it, write the words down, and listen to what I'm saying. All right, so there's a number of things in our blood, and things that we forget about is our plasma, first of all. Okay, and you can see this blood ship here is separated out. It might have just been left standing up, and what happens, it does actually separate out into its components based on what's heaviest. So you can see the red blood cells sink to the bottom. You've got this, what's called a buffy coat, sitting here in the middle, and that is our white blood cells and our platelets, and up here is our plasma. Our plasma is the liquid component of our blood. Without it, it's not going to work, okay? It's not going to flow. It's not going to have anything to dissolve those minerals and nutrients that it's delivering to the body. So it's mainly water, got some mineral ions, some protein, sugar, fats, amino acids, and it's about 50 to 60% of our blood volume. So that's quite substantial. And we talked about blood glucose, and this is the kind of place where this is dissolving. Right, now, somehow I find this image quite gross, but that's essentially what blood is. We often just see it as the red because we only see the red blood cells because they are quite prominent, really. But it's that yellowy plasma, and they call it liquid gold when you donate it at the Red Cross. It's a really interesting way of donating. We'll have a chat about that in class. And it can take about an hour. But what they do is they take all your blood out. Not all your blood. They take out a little bit of blood at a time. They spin it in a centrifuge so that the red blood cells sink, and then they actually take all the plasma off the top, and they give you your red cells back. So plasma is made up of 90% water, and the rest of it is all these other things that are, so there we go, the proteins and all the other things. All right, red blood cells. Here's our fun little guy. They're also called erythrocytes. All right, we're going to learn some more scientific names for some of these cells later on, and it's the only human cell, without a nucleus. Now, the reason they do that is because the only purpose these guys have is to carry oxygen, and that is it. So to do that, they need to actually have hemoglobin, and they pack themselves out with so much hemoglobin that by the time they are mature and they have enough hemoglobin ready to do their job, they just don't have room for a nucleus. So they spit it out while they're being formed in the bone marrow still. Now, it's about 40 to 50% of blood volume, and that is why our blood is so red. Right? The oxygen is binding to the hemoglobin, but the carbon dioxide is also binding to the hemoglobin. So it's a carrier protein that is moving things around the body. Now, hemoglobin is a protein. We've talked about that before, and it's got 2 subunits in adults and 3 in fetuses. And we'll come back to why that is down the track. Well, here we go. Now, fetal hemoglobin has a higher affinity for oxygen. It needs to grab that oxygen at a sort of greater strength than the mother's oxygen. Again, we'll talk about that later. And proteins on our red blood cells give us our blood type. So you're an A pos or a B neg or something like that, or an AB. That is a protein sitting on the outside of this red blood cell membrane, and that's what gives us our a blood type that we know. Right, so if you have a look at a blood smear down a microscope, that's what you're going to see. And if we talk about the shape of these guys, they're called biconcave discs, and they have a little area that's like a donut with the hole that hasn't quite been punched out yet. So when you see them on the microscope here, they look like this circular thing with a little area of central pallor. That's what they call it. So it's a little bit lighter in the middle. Biconcave discs with no nucleus, and they carry oxygen. There we go. So from the top, that's what we're going to keep seeing, and that's what we see in the blood slide. But really, they start to stack up when there's a clot, because that's what clotting is, your blood coagulating or sticking together. So that's more of an electron micrograph. Okay, so red blood cells are very, very susceptible, shall I say, to different concentrations of salt. You hear this isotonic a lot. You hear it in like Gatorade or Powerade. And isotonic means that the concentration of salts inside is the same as outside of the cell, right? So if these guys are sitting in a concentration of salt water, say, or your plasma, where the salt concentration is exactly the same, it's all good. The amount of water that is going through osmosis and diffusing out is going to be the same as the amount coming in. The concentration gradient is the same, so there's no stress on them. However, if there is more water on the outside, I'll just pause and have a chat. Right, got it sorted. If there is more salt on the inside, so it's a more water concentrated outside and more salt concentrated on the inside, what happens is water starts to rush into that cell, okay? Hypotonic, meaning lower tone or lower salt concentration. So the water rushes into the cell and unfortunately they start to burst. Now the flip side of that is if the red blood cell is sitting in a hypertonic, so there is more salt on the outside of the cell, then the water rushes out of the cell and they start to become wrinkled up and dehydrated essentially, right? I mix these up quite a bit, which is why I had to pause and think about it, because hypotonic, we are talking about the concentration of the salt outside of the cell. Okay, white blood cells. Here's our white blood cell guy, right? They are called leukocytes. And they only make up a tiny amount of your blood volume, not a lot. They can actually get out of your vessels, your blood vessels, and travel around outside only for the purpose of grabbing invaders, okay? And that is what they are doing. They are our protection, they are our security guards. They are made in the bone marrow and the thymus, and that's where they're matured, and before they get spat out into the peripheral blood, they have to be mature. If, for example, you start seeing lots of immature ones, it means the bone marrow is getting too full and it's starting to push them out when they're not ready, and that can be a sign of something a little bit more sinister. So they seek out foreign material, bind and flag it for removal. We'll have a bit more of a chat about how they do that, but they produce proteins called antibodies, and they're like exactly what I said, they're flags. They're little flags, they stick it to foreign invaders and they say, hey, this isn't right, can someone come and clean up this mess? Clean up in L5. There are 5 main kinds of white blood cells: lymphocytes, neutrophils, monocytes, eosinophils, and basophils. So they all have a slightly different job and they all look very different as well. So if you're looking down a blood smear, down a microscope to look at a blood smear, they're the kinds of ones that you would see. Now our lymphocytes and our neutrophils are our most common. All right, these are quite common, but you don't see them as often. And these guys are particularly rare, and these guys you're really lucky if you can see a good basophil down the microscope. So when you look down a microscope, these are the kinds of things you'll see. So you can see that we've got our red blood cells, no worries. Here's our white blood cells, and we'll get to these in a minute, which are platelets. So this is a pretty spectacular field of view down a microscope because you can see all 5 kinds, which is very rare. Right, so our neutrophils are our phagocytic cells. That means they can actually take on board foreign invaders, okay? They take them up, phagocytic. They are segmented in the neutrophils and they're like twisted lobes. They have multilobular nuclei, and they're like getting a guy that makes balloon animals. So you're getting a long strand, you're twisting it, you've got one segment and another segment. There are granules in these ones, and there's also granules in our second and third kind, right? So our eosinophils have bright orange granules. They are very easy to pick down the microscope, and they are very reactive during allergic reactions. So if you are having some kind of rash or you're allergic to maybe a moisturizer or a sun cream or something, these guys will be right at the seam. They can spit out these tiny little granules and cause more of them to come to the scene, kind of like raising an alarm. All right, our basophils, quite rare. Again, you can see all 3 of these are quite granular. They all have the granule, and these ones are our basophils. They also have multilobular nuclei, but they're not as many lobes as, say, our neutrophils. Cytoplasmic, that means they've got quite a lot of background staining around the inside of that cell there. They have very dark granules, and they release histamines to instigate the inflammatory response. So you can see the eosinophils and the basophils have a very similar job there. All right, these guys are called our monocytes, and once they migrate into the tissues, because these are the only ones that migrate into the tissues, they become known as macrophages, and they indeed are phagocytic as well, so they can uptake foreign invaders. These guys are our lymphocytes, and these are our main producers of antibodies. Now, an antibody is a protein that will stick to a foreign invader to flag that it shouldn't be there and that someone else needs to come in, phagocytose it or uptake it. All right. We often hear people talking about B cells and T cells and even NK cells, often when you're talking about, say, leukemia, and we'll talk a little bit more about that later. Here's a beautiful neutrophil chasing bacteria in your blood. Now, your bloodstream should be sterile. It shouldn't have any bacteria in it whatsoever. However, sometimes it happens, okay, and that's when you start to get sick. So this is an awesome, this one's a GIF. You can see the YouTube video here if you like. example of what they're doing. They're chasing until they will indeed engulf it, and then eventually they will just pull it apart and recycle its parts or use it, expel it as waste. Platelets. I don't have a platelet toy yet. Right, platelets are our final one, and they are called thrombocytes. What they actually are cell fragments of a larger cell. Now, megakaryocytes are these monstrously big cells, and they break apart to form tiny little platelets in our blood. They assist in clotting by gathering at the site of a wound and begin clumping. So we talked about, say, and we know that platelets stick things together, but there's also those proteins in our blood that are called clotting factors, and that complex clotting cascade, that signal transduction also works. So they work together. All the proteins in your blood plus your platelets work to clot at the site of, say, an opening of a blood vessel. It might be open to the external world. It might only be open to the inside of your world, and you have internal bleeding, and that's what a bruise is. So platelets are going to be really tiny amongst the red blood cells when you look at a microscope. Sometimes you can see a bigger chunk of a megakaryocyte. That's not quite a megakaryocyte. A megakaryocyte might take up the entire field of view there. But yeah, they come in all different shapes, sizes, densities, darkness when they stain. You can start to see here, this is blood that has been smeared out, put under the microscope, and it's probably from blood that has already started clotting, because you can see here all those platelets have started to clump together. That's what you don't want to see, but it will happen. And it's certainly not a good thing to happen in your peripheral system. So that's what a blood smear looks like, right? That's generally a good field of view. You can see a whole lot of red blood cells. They're not touching, but they're close together. They're not overlapping too much. And you will see different thicknesses and spreads on a microscope slide. And then you've got a neutrophil here and another neutrophil here, because they're the most common ones that you'll see. And you can start to pinpoint all the platelets around the place. So when we start to look down a microscope, they're the kinds of things that you will see.